All right. So we're going to be looking at hydrocarbons. So last week we had studied the introductory stuff for organic chem. All right. Now a hydrocarbon. The name kind of self-explanatory because of the fact that these compounds are made up of hydrogens and carbons only. There are two sources of hydrocarbons. You could get it from natural gas. Natural gas actually has methane with small traces of ethane, propane, and butane in it. We have petroleum, which is also known as crude oil, which is a complex mixture of hydrocarbons. Now, crude oil by itself, when it is mined for, all right, it's not really usable in that oil structure because crude oil is usually a black, thick oil. The mixture has so much combinations of hydrocarbons in it that it is deemed useless by itself. However, right, when it is separated, right, it will have, the fractions of it will have more uses than the oil by itself. So crude oil naturally contains a lot of sulfur, so it has to be treated to remove sulfur, right? Because if you start to heat this and the vapors start to go up into the air, it could create pollution. So you don't want that happening, so you treat it, you remove the sulfur first and foremost. When the crude oil is then heated, the vapors will be going up into a fractionating tower, where different parts of the tower is collecting different fractions, right? When these fractions are received, now we move on to the next part that is called cracking. Even though distillation will break down the crude oil, some of the fractions are still too large. So cracking breaks your large hydrocarbons back down into smaller ones. This is what Petrotrin used to do. They had one side that used to do the distillation of petroleum, and then the other side that the cracking. Now, there are two types of cracking. There is the thermal cracking that uses heat alone, but the most commonly used one is catalytic cracking because it's faster. Catalytic cracking uses heat plus a catalyst. When you break a large hydrocarbon down, you're going to be ending back up with an alkane and an alkene. So my example there I have is pentane, right? When pentane is broken down, you're going to have propane being formed, and they're going to have ethene being formed, all right, which is your alkene. Anybody has any questions based on that so far?
No, ma'am.
All right. So I'm going to allow you to take this down. When you're finished, I'll give you the next slide, and then we're going to look at the uses of crude oil. We have refinery gas, right? Now, this is a gas that is used in your household, domestic use, gas cookers, and it's used for the manufacture of petrochemicals. Gasoline is needed for the internal combustion engine, so like your cars, light aircraft, small airplanes, something, right? We have kerosene, which is also known as pitch oil. It is used for the fuel of jet engines, kerosene lamps, paraffin oil, cooking stoves, and it can actually be broken down into smaller hydrocarbons. Diesel is also known as diesel oil. It's used for diesel engines, lubricating oils and waxes. We use them for like fuels in those heavy factories and ships, lubricants, because you know all of these machinery needs some lubricants. We use it as polishing waxes for our vehicles, petroleum jelly, wax papers, and candles. The higher one, which is asphalt, which is also known as bitumen, it's used for road surfacing. So I'm going to allow you to take this down. When you're finished, let me know.